So for today's video, we are going to differentiate right triangle and oblique triangle. So the first thing is that when we heard a um, right triangle, it involves what a 90 degree angle. Yeah. And so um, the opposite side of the 90-degree angle is the what the hypotenuse, or we can label it as C, and the two remaining legs are the A and B. A and B. And, one thing for sure that when we uh, heard the right triangle is that um, it comes up with our mind the Pythagorean theorem, which the sum of two legs is equal to the hypotenuse. So the sum of two legs A plus B squared is equal to C squared. And also we can label this in terms of what trigonometric function. Let's say this is theta. So let's say that sine theta is equal to what? By using the SOHCAHTOA. SOHCAHTOA, which means sine is equal to the opposite over the hypotenuse, which means the opposite over the hypotenuse, or the A over C in given these terms. And also cosine theta is what? Adjacent over hypotenuse. So the adjacent here is this length here, the longest leg. No, the longest leg. So it will be the um the adjacent over the hypotenuse, or simply B over A. I mean B over C. C rather. And next is the tangent theta. Tangent theta is what? The opposite over adjacent. So opposite over adjacent is will be our angle theta. The opposite A, or the opposite over adjacent adjacent is this leg here. So simply A over B. So those are the things what we need to understand and learn about the right triangle. So in this next triangle is the what? The oblique triangle. So oblique triangle is that that it has no 90-degree angle. It has no 90-degree angle. So by the definition, oblique triangle is that it has no 90 degrees angle. So there is what we call a the example of oblique triangle is the obtuse angle. One of the obtuse angle is that it one of the angle is um, greater than 90-degree angle, and two of the angles are acute angle. So let's say that this angle here is 120, and the remaining angles are um, 30. So said that in the sum of three angles in a triangle is 180, but the difference of these two triangles is that oblique triangle has no 90 degrees, and the right angle, it's from the word right triangle, is it has 90 degrees. So those are the things we need to apply or understand before we proceed to our next um, discussion. For today's video, we are going to um, solve a real life problem involving a right triangle uh, problem solution. So we have here an example, uh, a problem that is a five a 50 meters rope 50 meter rope 50 meters rope is attached to the top of the tree and extend to the ground and anchor to the and extend to the ground and anchor to the ground. If the rope makes an angle of 55 degrees with the ground, find the length of the base of the tree to the foot of the rope. So let's say that this is the top of the tree. This is the top of the tree. This point here is attached the top of the extend to the ground. Let's say here, this is the ground. All we need to do is to connect this example. This will be the rope that is attached to the ground. And now, if the rope makes an angle of 55 degrees, the ground, so let's say this will be the top of the tree. Let's say this is um, this is B, and this is C. And this will be the top of the tree, elevated to the ground. So and so you could say that if the rope makes an angle of 55 degrees with the ground, so 55 degrees, this will be 55 degrees. And now a 50 meters rope is attached to the top of the tree. So this will be the rope attached from the top of the tree to the ground is 50 meters long. So with this information, we could say that we are going to find the length of the base of the tree to the foot of the rope. So length of the base of the tree. So this will be our tree. Length of the base of the tree. This is A. So we are now finding the length of the base of the tree to the foot of the rope. So here's what we need to do. So since we are given the the um the longest length of the triangle and the given the angle of 55 degrees, we could use the cosine, or given that the SOHCAHTOA, which means that we are using the cosine. Cosine cosine of cosine of angle 55 degrees is equal to the adjacent, which is the adjacent. Let's say we are looking for the adjacent side here. The respect to the problem, the adjacent side is x over the hypotenuse is 50. So all we need to do is cross multiply cosine. Let's say we have a 1 here. So cosine 55 degrees times 50 is cosine 55 degrees times 50 is equal to what? Is equal to x. So the cosine 55 degrees times 50 is equal to the x is equal to 28.6788 if you use calculator if you want to know the exact answer. So in our next example, we also involving about the right triangle real problem scenario. So in this next problem is that a flying aircraft is dropping a bomb from its position to the target in the ground that is 1,000 feet away. Its altitude of aircraft is 250 feet. What is the angle? What is the angle if the bomb reaches to the ground? So the first thing we need to do is we say that a flying aircraft is dropping a bomb from its position. So let's say this is the flying aircraft. This point here. Let's, let's label this as the EA, and that is the bomb from its position to the target in the ground that is 1,000 feet away. So 1,000 feet away. uh, the next thing is its altitude of aircraft is 250. So 250 from the aircraft to its altitude is 150. So let's say this is B. The altitude is 250 feet. And the next is the flying aircraft is dropping a bomb from its position to the target in the ground that is 100 feet away. So 100 feet away, this will be 1,000. I mean 1,000 feet away. 1,000 feet away. So we could connect this, or um, we can form a right triangle. So in this case, what is the angle if the bomb reaches to the ground? So what is the angle if we drop the bomb here all to this target? And so what will be the angle? So we are now looking for the angle theta. So since we are now given this information that according to Sukotowa, sine is equal to opposite of hypotenuse. So now the opposite of this angle is 250. Sine is equal to the opposite 250 over 1,000 is equal to 0.25 sine theta. And so for now, we are now dealing with we are now finding the angle. Since we are looking for the angle, uh, we will always use uh, the inverse sine, or the so in dealing with looking for the angle of this problem, we will use the inverse sine of theta, which is the inverse sine of 0.25 is, so the inverse sine of 0.25 is that 40.48 48 degrees. So that's how you solve to find the angle of a right triangle, given the information of uh, the opposite the opposite side and the hypotenuse.